Hi, my name is Kristen Salgado from Period 2, and this is my real-life related rates project. My dad, John, is 5.75 feet tall. He is walking towards a 24-foot tall street light at a constant rate of 4.67 feet per second. At what rate is the angle of elevation changing if that angle is measured from the horizontal line joining the top of John's head to the top of the streetlight when John is 12 feet away from the light? This problem represents a right triangle. From the information given, we know that the streetlight is 24 feet tall and John is 5.75 feet tall. This means that the length of the remainder of the streetlight is 18.25 feet, which represents our y value. Also, John is 12 feet away from the base of the streetlight, which represents our x value. Our angle of elevation is represented by theta when John is traveling 4.67 feet per second towards the streetlight. So what we are trying to find is d theta over dt when x equals 12 feet. And first we know that dx over dt is negative 4.67 feet because he's going towards the streetlight. Because our problem is a right triangle, we can use the Pythagorean theorem, which is a squared plus b squared equals c squared, to find the value of c. So first we would do 12 squared plus 18.25 squared equals c squared, which becomes 144 plus 333.0625 equals c squared. Adding those together and taking the square root of both sides becomes the square root of 477.0625 equals c, and c equals about 21.8418. We know that tangent is opposite over adjacent, so tangent of theta would be 18.25 over x. Then we take the derivative of both sides and we get secant square root of theta times d theta over dt equals the derivative of 18.25 times x to the power of negative 1. To find secant square root of theta, we know that secant of theta equals 21.8418 divided by 12. When we square the equation, we get 477.0625 divided by 144. This means that secant square root of theta equals 3.3129. Then we take 3.3129 and plug it into our equation for secant square root of theta, and we get 3.3129 times d theta over dt equals negative 18.25 over x squared times dx over dt. Then we know the values of x and the value of dx over dt, so we replace these in the equation, and we get 3.3129 times d theta over dt equals negative 18.25 divided by 12 squared times negative 4.67. When we simplify, we get 3.3129 d theta over dt equals negative 0.1267 times negative 4.67. Then, which becomes 0.5927. And we divide both sides of the equation by 3.3129, and our result is d theta over dt equals 0.1789 radians per second. These results mean that as John is walking at a steady rate of 4.67 feet per second towards the streetlight, the angle of elevation from the top of his head to the top of the streetlight is changing 0.1789 radians per second. Thank you.